Hello and welcome to another of our short introductory videos relating to practical temperature metrology. And in this session we're looking at different types of ITS 90 fixed point cells, from the freezing point of indium to the freezing point of copper, so from about 156 to about 1084 degrees C. So what is an ITS 90 fixed point cell? I'm going to go through different types. This particular one, we call it a slim cell at ISTEC. It's one of our smaller cells. It's as good an example as any. So I've got a graphite crucible which is in this metal enclosure, and inside the graphite is the pure metal. This one contains pure tin. It's 6 nines pure, so it's 99.9999% pure or better. And there's a thermometer well in the centre. The cell's sealed, but the thermometer will come into the thermometer well and sit inside the metal enclosure, not in direct contact with the metal. But to use the cell, I need to put it into a furnace or some sort of calibration equipment to raise the temperature. So tin melts at about 232 degrees. So I'll raise the temperature to a little above that until the solid tin melts, and then I'll lower the temperature of the calibration equipment so the liquid tin slowly freezes. As it goes through the phase transition from a liquid to a solid, we get a known and constant temperature, and that's used as the point to calibrate our thermometers. So as I mentioned, there are quite a few different types of ITS 90 fixed point cell. This is a metal clad cell, and we call it a slim cell, and we use that in some apparatus. This is a product from ISTEC called the ISO tower, and this product combines a heat pipe and the furnace with the cell into one integrated device, and we can use the ISO tower as a standalone system to calibrate at the ITS 90 fixed points. There's larger cells. This is what we call our optimal cell. So it's the same as the slim one, but physically larger. The benefit is there's more metal inside the cell. The thermometer coming into the cell is immersed more into the metal, and we can get a lower calibration uncertainty. With a metal clad cell, they're more robust than the quartz glass type, but traditionally ITS 90 fixed point cells have been made in glass cases. But at ISOTEC we can offer up to the aluminium point in a choice of metal clad or quartz glass clad. So here we have a quartz glass aluminium fixed point cell. We can see through the glass the graphite crucible. Inside the graphite is the pure aluminium, and we can melt and freeze this in a furnace the same as the other cells. These optimal cells we would use really with primary SPRTs. The smaller, more affordable slim cells are good for working standards or very high accuracy industrial thermometers, whereas these would normally be used with primary SPRTs. And the ISO tower sits halfway between the two. The uncertainties are almost as good as these large cells, and yet they're a lot more affordable, and the performance is better than the metal cells. The ISO tower is patented, and it's really quite a useful device. We've got separate information on that here. So these cells are all sealed, and that makes them convenient to use, and the majority of cells in use are sealed cells. But this cell is an open cell, and what that means is it's a similar construction. We've got a graphite crucible with the pure metal, and you can see it's in this much longer glass tube, or with this port here. So this would be connected to a manifold which would enable us to vacuum out the cell, then backfill it with an inert gas, and to set the pressure. So with an open cell we've got the advantage that we can measure and set the pressure inside the cell, which has got an advantage over the sealed cell because you can't measure that pressure. So for the largest NMIs they tend to use the open cells, whereas most labs will use sealed cells. There is an added benefit with the open cell, that they're easier to transport. This sealed cell is very fragile, and we'd always recommend it's hand carried, and if it's going internationally it needs to be hand carried on the aeroplane. The metal cells can be shipped, and these cells can also be stripped down and shipped. With higher temperatures, the cells can have a finite life. So at lower temperatures, we've got cells in use for more than 30 years. But at higher temperatures, and at the copper point of 1084 degrees C, it's very close to the melting point of the glass. So if this was a copper cell, if the glass became spoilt, I'd have quite a headache. But if I had an open copper cell and the glass became spoilt, I could simply change the outside glass, retaining the crucible and the copper. So there's a benefit there, and there's certainly an advantage in using the open cells at the copper point. So some practical thoughts about using cells. In terms of storage, we recommend storing the cell vertically, and in our case it's a good way to store it. Large laboratories might have a rack, but it's best to keep the cells vertical. I've been handling this cell so there'll be some grease from my fingers on the glass. So I wouldn't want to put this into a furnace because at a high temperature it can leave a mark on the glass and that could form a weak point. So before I was to use the cell at a high temperature, I'd wear some powder-free latex gloves. I would wash and clean the cell with acetone to remove any grease. And these cells don't go directly into the furnace, they go into, we call it a basket, with some insulators and some metal reflectors. Again, I'd clean all the metal parts. I'd fire those at a higher temperature than I'd use the cell at. And then I'd put the cell into the basket, clean, and then put it into the furnace. So it's important to keep cells clean, and it's good to store them vertically. And many labs will simply store the cell in the furnace and leave it in the furnace when it's not in use. So a common question is, if we've got an ITS-90 fixed point cell, and the temperature comes from the purity of the metal, and if we know the pressure, we can be very confident in that temperature, then does the cell need a calibration certificate? Now certainly in the past, the majority opinion was probably no, it's a fundamental constant of nature. But today, in the ISO 17025 world, we need traceability. And so cells need to be calibrated compared to a reference cell. So it's usual now for all cells to have some sort of calibration certificate to establish the traceability. Another question is, what's the lowest uncertainty we can get with the calibration certificates? Well, we've got a separate guide on that, and we've got a link where you can download that, and we show the different uncertainties for the different types of fixed point cells and the different services that we offer. So thank you for watching this very short introductory video. It's a complex subject. We've got a lot more information on the website. There are many technical articles, some journal articles, some comparisons of cells, as well as details of the different types of equipment, from the slim cells, the ISO towers, the optimal cells, and all that information can be found on the website. And finally, be sure to like and subscribe to be kept up to date with new videos from ISOTech.